Who's excited about DevOps talks? Woo! Who's excited about managing servers? Good, that's good. You're at the right talk. Look, hi. Thank you so much for being here today to come and listen to this talk. Very excited. I've got amazing speakers here. Today, I'm going to talk a little bit about, basically, I'm going to tell you a story. I'm going to tell you the story of building one of the world's first web platforms, really at scale, that was built with entirely serverless architectures. And I'm also going to give you 10 handy tips for building a platform and a company with a serverless approach. So, who am I? So I'm Sam Kroonenburg. I'm one of the founders of A Cloud Guru. If you haven't heard of us, we're an online learning platform and training company. We train engineers in all things cloud. And we've built our platform technology entirely serverless. In fact, we're actually a completely serverless company. We've never run a server since starting the business about 3.5 years ago. And my party trick, to provide you all with proof, is a screenshot of our EC2 dashboard. Woo! Check out the Getting Started guide. So let me just move forward. There we go. So I'm going to talk you through our journey over the last 3.5 years, building this platform and launching our serverless platform before anyone was using the term serverless. That term didn't really exist when we launched, and it was actually before you could even call Lambda from the web. I think we're an interesting case study for businesses who are looking to invest in serverless technologies now, because in a way we've kind of been to the future and come back. So over the last 3.5 years, we've kind of been on this journey that a lot of companies are just starting to think about embarking on now. We've learn't where serverless technologies are a massive accelerator, and we've also learnt where they brought real challenges, because it's certainly not all rainbows and unicorns, as they say. So this isn't going to be your typical talk on deployment pipelines and functions and code. I'm going to tell you the story of building a serverless business and give you some insights that you can use if you are looking at doing something similar. So to start the story, just to give you some context, we started this a few years back with a mission to change the way that people learn cloud computing. I actually started the business with my brother, Ryan Kroonenburg, and he had put a couple of courses online back then about getting your AWS certifications, and they were just starting to attract some attention. So we got together, and my background's software development, and we decided to try to create the place to learn cloud computing online. We wanted to build a massive online community. We wanted to build the place that all IT professionals would come together and help each other and support each other in learning cloud. And yeah, it's been a super busy few years. We've now taught cloud computing, very proud. We've taught cloud computing to over 800,000 engineers around the world in over 170 countries. We've got offices in Australia, the US, and the UK, and we've got now got over 100 amazing dedicated employees who really share that mission and that passion for making education as democratized and accessible as possible. That's really what we believe in. So I wanted to start by just showing you the dashboard that we built and how it looks. And the reason I show it is because it's a rich experience. It's very responsive and it's very fast. And when we started, it might be obvious now, but back in the day, people were saying serverless approaches will never be suited to the web. There's too many latencies, cold starts take too long. It's not going to be a good user experience. It's better suited for back-end tasks. So I want to talk a little bit about our architecture. So this is like a really simplified version of our architecture today, how it looks today. So we have a fully serverless API running on API Gateway in AWS. That's backed by Lambda functions that expose a GraphQL endpoint. And that uses GraphQL schema stitching to basically stitch access to data across a range of microservices. And we have about 30 microservices today. So these microservices are built, again, entirely on AWS Lambda, backed by DynamoDB. We also use Firebase and Algolia effectively as like materialized views for the user interface. They'll access that to fetch data to show to the user. And we have DynamoDB streams invoking Lambda functions to guarantee that all relevant changes that hit the database will turn up, eventually in a kind of an eventually consistent way in our materialized views and can be accessed from the front end. So you have a level of guarantee there. Now, this was not the architecture that we started with, and I want to kind of take you through that journey shortly of how we got here. So why do we like this architecture? Well, all of the systems that we use, every single one of them is pay-per-use, and the unit of scale is incredibly small. It's function by function at the compute level. All of the operational responsibility sits with the vendor for these services, and the scope that we're responsible for managing is incredibly low. It's effectively at the function level when we're talking about compute, and there's absolutely no impact of idle time. We never pay for idle. So the cool thing is the costs of running our business scale almost perfectly with demand. So if customers are getting value from our product, we're paying. But if they're not, we're not. That helped a lot in the early days. So here's some stats of how the system looks now. This is what we've scaled to. And we've scaled to this level without ever having to rethink our architecture for performance purposes. We've never had to have those conversations like, oh my God, Black Friday is coming. What are we going to do? Everyone's going to hit the site. We just don't have those kind of conversations because of the systems that we use. So we have 268 Lambda functions across 30 microservices, 3.6 terabytes or so of data in S3, video files. Every day, 6.5 million Lambda functions are invoked, about 1.8 million API requests, and about 1 trillion S3 requests per month. And that's the cost, that's our entire compute bill for the company. $1,600, and that's our API bill. So $2,000 a month. We serve 800,000 customers with about 2 million API requests per day. Like, that's crazy. And that's our EC2 bill, of course. So yeah, I just want to, talk a little about how we got here and how this approach came about. And so we were there, this was mid-May 2015. We wanted to kind of launch this startup, and we wanted to kind of rocket off to market and see what we could do, but we had to find a way to kind of escape the gravitational pull of our normal lives. We had mortgages, we've got kids, financial commitments, and so we needed to get something to market quickly and just see if we had something that people actually wanted to buy. And so we needed to start earning enough income to be able to focus on this full time and really get it going. And the question we had was, how to get this off the ground. And I would always love to do these talks and say that I was, sitting there in the bath and I had an epiphany that we've got to go serverless. We've got to go serverless architectures. But no, I think like nearly all innovation, it starts with a constraint. And so the constraint was that I had 4 weeks to try to work out how to build a school. And my wife, incredibly supportive, big supporter of mine, encouraged me. I basically had 4 weeks available to me, and she encouraged me to use that time instead of going on our family holiday that we had booked to build the school. So we cancelled the family holiday, and with our 4 kids, we flew to live with my in-laws for 4 weeks. And I basically locked myself away in a bedroom for 4 weeks to try to work out how the hell to build a learning management system. And so to be successful, this had to have a video player, a quiz engine, an online store, had to check out, had to scale effortlessly and not need a lot of operational support to run because like when I'm asleep, there's no one to do the ops. So I was really daunted by the scale of this, and I was from a background of traditional software architectures, 3-tier architecture, and I thought I just don't see any way I could do this. So my first attempt was to grab Moodle, like some off-the-shelf LMS software, and try to configure it, reskin it basically. But that was an absolute disaster because you just have you can't have control of your own product, and this is our core product, the school. So I started stressing that like maybe this whole idea was a waste of time, and I'd cancelled the family holiday for no reason, and I wasn't going to be very popular with my wife. So I went back to the drawing board, and I started thinking, well, okay, how can I outsource as much of this as possible? Like, what's already a solved problem out there, and then what accelerators are available to me? And then I remembered playing with Auth0, which is authentication as a service. And it was really new at the time, but I remember being really impressed by it. And in previous projects, I had spent weeks alone just implementing user authentication. So, creating a sign-up screen, a login screen, a forgotten password wizard, social media sign-ins. That can be a big task for developers to build. But with Auth0, you just create an account, drop a few lines of JavaScript into your web app, and then all of that is done for you. Even the login box is rendered by Auth0. And then I also remembered playing with a service called Firebase, which, as you all, I'm sure a lot of you know now, is owned by Google, but back then hadn't been bought by Google yet. And Firebase was a NoSQL database that was done quite differently. It was actually built for the web. So Firebase's database can connect directly to the web browser. So meaning that when your site loads in the web browser, it can talk directly to the database through the web, as in your user talks straight to the database, and there's no intermediate web server required. So now I was able to put a whole bunch of course information in this little Firebase database, like this is the title of the course, the descriptions, the icons, here's the lessons, here's some quizzes. And then our site could access it directly from the user's browser, could call to the database and access that code just with some front end. We originally built this with AngularJS. And so I didn't need to build this middle tier layer to act as a proxy, basically, between the front end and the database. And this saved a huge amount of time. It was less time I had to worry about plumbing and infrastructure and getting these web servers up, and more time that I could spend building actual features to help people learn cloud. But there's some things you can't do in the front end. I think we all know that, right? Actions that load maybe, say, private or sensitive data. Maybe you've got to fire off emails to all your customers and you need to load their emails, or maybe you've got to call a payment service like Stripe and with secret keys that you can't expose to your customers. So some things just can't be done in the front end. And this meant that I needed a web server, which I found really, really annoying because I now only needed a web server to do a very small handful of things. But now I had to suddenly worry about managing the servers, the infrastructure, monitoring it, scaling it. And then I remembered WebTask. And WebTask was this service actually built by the Auth0 guys that you could upload a single JavaScript function to, and it would expose that function at a HTTP endpoint. And so you could make a HTTP call to invoke that function, and it would return a response. And it was originally built as a way to build small webhooks without having to stand up a whole server. So I realized that for the very few protected actions that I needed to run in the back end, like authorizing payments, we could do them with WebTask. So I would write a small amount of JavaScript code. There's me. It's my amazing JavaScript. I would upload it to WebTask. It would give me a HTTP address back. Then our front-end app would call to WebTask, call that endpoint to authorize a credit card payment from a customer. WebTask would then run. It would call out, run in a protected environment. In the cloud, it would call out to Stripe to finalize the payment using our secret keys. And then once finalized, the function would write a record into Firebase to record, John purchased a course. And then because Firebase used WebSockets, it would automatically sync that record straight back to the user's web browser and allow them to watch the course that they just purchased. And no need to even refresh the page. So that was cool, and then after some time, API Gateway came out, and we could have finally invoke Lambda through HTTP, and we were able to move away from WebTask and do this natively all in AWS. And so, with a model like this, we had a truly standalone front-end app. If you think about it, the HTML, JavaScript, and CSS here didn't need to be served by a web server at all. So we could literally just plonk it on a CDN like CloudFront, and distribute our assets all around the world with fast load times. So this was, really like a basic rudimentary serverless architecture. We just didn't know what to call it at that point. There was no buzzwords yet. So the entire thing was, served by web services that manage provisioning, monitoring, and scaling for us. And they provide us with these really great SLAs. And best of all, everything was super low cost, and the bills scaled really, really tightly with usage. And look, so this was awesome for request response scenarios. It's a good architecture for that. User does something on the site, short action, it runs a cloud function and it returns a response. But then it was, okay, that's fine, but how are we going to kick off longer running processes? How are we going to do something that could take hours or half an hour? Serverless functions, I think at the time only ran for a minute, Lambda. And what if it has multiple stages? And then, it turned out that as we got into this, that serverless architectures are actually really, really well suited to tasks like this. They allow you to compose these really robust event-driven pipelines with cloud functions. So the first thing we built like this was an entirely serverless video transcoding pipeline. And you've probably seen examples of similar things around. It's quite a popular use case. So Peter is one of our instructors. He decides he's got a new lesson. He's recorded a new lesson. He wants to upload it to our students to watch. His browser uploads it directly to S3. Now that bucket is configured to invoke a Lambda function. So whenever a new file turns up, our Lambda function runs. And we write this little Lambda function that says, okay, cool, we've got a new video file. Let's create an elastic transcoder job. We want to transcode this into 1080p, WebM, 720p, HLS, whatever we need. So it creates that job. Now, that job is configured to put the transcoded files into a destination S3 bucket. It's pretty handy. So we hang a Lambda function off that to say, hey, whenever a new transcoded video file turns up in this bucket, let's have a look at it. Let's look at the file name. Okay, it's this video. This is a 1080p version. Great, we're good to go. And that Lambda function will write to our Firebase database to say, hey, we've now got a 1080p version of this video, of this lesson. Let's make it available back to users in the browser who are there. And so the whole thing is event-driven without any polling or anything like that. It's just push, 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 push the whole way around. And you can obviously, this is very simplified. You can deal with error cases and have different ways of dealing with that as well. So that was cool. So we built this, and we launched the thing at the start of September 2015. Woo! And yeah, so we had liftoff. And the business started gaining customers really fast. It was pretty crazy, and people were really starting to enjoy our content and our teaching, and our website was delivering on its core functionality. We didn't have to worry about monitoring or operating the infrastructure, so we could keep the team really small and build some funds in the business. And we didn't take any investment in the business for about the first 18 months. We just built the business out of cash flow, and we were able to do that because our hosting bill was so small. And the thing I think, about this story, or like what happened here, that's not the most incredible architecture, right? But it shows that serverless approaches solve a need that wasn't solved before. So they allow for that really incredibly quick ideation and build and improvement speed to get things to market. I didn't choose this approach because there was a popular buzzword out there and all the cool kids were going serverless. I chose it because I had 4 weeks to build an online school and I had absolutely no other way of doing it. So it was that constraint, and it shows, I think, through that constraint that this really does solve a problem that wasn't solved. So yeah, there we were kind of riding that serverless rocket. We escaped the real world. We managed to quit our jobs and try to give this thing a go full time. And I think just like a rocket, it gave us a whole bunch of accelerators to move faster. But then we also realized that things were a little different up here. They were a little different in this new model, and it wasn't exactly like previous companies that I'd been in. And serverless brought new opportunities, but also a whole bunch of new challenges, and so we had to adapt the way we did things. So I promised you 10 tips, and here they are. So number 1, no ops. Yes, there's ops. There was this myth early on in the serverless movement, as I'm going to call it a movement, why not, that serverless meant there was no ops. And it absolutely, to be clear, it does not mean that. I don't think anyone really believes that anymore. But it does shift the responsibility of ops, and it changes the makeup of your team. So you're now in a world where third-party services, third-party companies do so much of the heavy lifting for you. And you have to consider those services as part of your ops team. And if you ever look online, Charity Majors does some really great talks about this. If you use AWS like we do, then Amazon are running the servers. Amazon are part of your ops team. Or Xero are literally letting people log into your application. Something goes wrong there, they're part of your ops team. Algolia, part of your ops team. Firebase, part of your ops team. So you need to have a really good understanding of your dependencies on third parties and clearly understood and documented lines of escalation in the event of failure. If something goes wrong in the middle of the night, in a third-party service, and nearly every single time we have an outage on our platform, and we don't have many, but when we do, I would say 90% of the time it's a third-party issue. The person on duty needs to understand who to work with. Who do you work with at that company? So you'll still do ops, but now your development team will be much more responsible. Number 2, don't look for serverless developers. don't. We learned really quickly not to kind of advertise to hire serverless developers with serverless experience, because there are just so few out there that you'll limit your options. And there are, despite what maybe some job ads might ask for, there are no serverless developers with 5 years experience. That does not exist, okay? So when you're hiring, think about what you're looking for. If you think about it, like we just talked about, your developers are now more responsible than ever for ensuring the smooth operation of your system, automating deployment pipelines, anticipating the many ways in which the system can fail, robust monitoring systems, failovers. I've got to think about all this stuff. So you no longer want to hire that ace developer who obsesses over, the elegant code, the beautiful, super efficient algorithms and great data structures. You want the developer who cares about alerts, logging, how are you going to track and correlate events across a distributed system? How are you going to deal with rolling back a bad deployment? So my advice is to hire for responsibility and accountability when you're building out your engineering team. And I think the other thing here is that you've got to encourage and reassure candidates in this world. So when we first started hiring, we thought that people just flock to work for us because the technologies we use are so kind of new and cutting edge and fun. And we learned a valuable lesson really quickly. So we would advertise hey, come and work for us and you're going to work on Lambda and DynamoDB and Kinesis and CloudFormation and all these cool things. And we talked we're entirely serverless, cloud native, heavy automation. And no one applied. We scared a lot of people off because people were just self-selecting out. They were not applying because they thought, that stuff sounds cool, but I don't have any experience. Someone else is going to beat me in this process. I'm not going to get through. So we had to change it up. And what we learned is that really what resonates with people and really what we're looking for is to be able to say, hey, we use the coolest, latest cloud technologies, and you're going to learn a lot working here. It's going to be a lot of fun, but we're also, we're not looking for serverless experts. We're looking for smart devs. We're looking for smart developers who care about building quality systems and robust engineering practices. So basically saying we value learning and constant improvement, and we're going to support you all the way. So we found that just by exciting candidates and then really encouraging them to apply and get them excited about the opportunity, and then reassuring them that we're going to be there for them was much more effective. Another thing that's really important in this world, I think, is to use a community. And it's true in any technology community, but I think anything that's as new as the kind of the serverless world and serverless approaches, community is paramount. You will come up against challenges, and I guarantee you, every single other person in the community is coming against the same challenges. Everyone's facing the same thing. So, we learn a lot from the community. So we actually run a conference called Serverless Conf in the States and Europe. And we learned so much through that community. So I learned about Algolia from Joe Emerson, who came to the very first Serverless Conf and talked about how they use it. And it transformed the performance of our website. We've used technologies that have come out of the serverless community around the serverless framework, a whole bunch of plugins, and then we've contributed back as well. So there's some really good resources if you're interested in this way of building. This sounds like a shameless plug, but I guarantee it really is useful. We have a site, a blog, read.acloud.guru. We don't write any of these articles. This is a community-sourced journal. So the community write these articles and submit them, and we curate it. So a lot of really interesting serverless discussions on there. I also suggest reading the News Stack, Serverless Zone, if that's still around. I think it's still around, yeah. And there's a lot of good online publications like that. There's a community serverless Slack that's very active and a lot of people use. So have a look at that. And Twitter is a really great source of discussion. And here's some people I recommend following. Get a picture of that. Follow these people. They're really interesting, insightful people who've really helped to pave the way in the serverless community and come up with new approaches. And this is an interesting one. Expect to pioneer. serverless is a young ecosystem, and while it has matured a lot more, your team are still going to be spending time developing patterns and modifying frameworks for these systems. It's not a drop-in Rails and Go solution. One click, new project, I'm good to get going. There's still a lot to do. And we've spent, if I look back, we spent time rolling our own build systems from scratch, and then we threw all that out when the serverless framework got released, which is an open source framework for deploying and managing serverless systems. It's really good. And then we spent time building plugins for the serverless framework. Spent a lot of time on that, and then they would roll in basically the same functionalities of the framework. We'd throw out our plugins, right? But that's good. The ecosystem's maturing. So I think teams that can overcome working with that young ecosystem will really excel. You're going to lose some time building that tooling, but overall your team is going to be able to focus more on product, less on traditional operations tasks. And I think the important thing is that you're going to have a much more engaged team. Because what's more fun? Building new tools and contributing to open source frameworks, or managing servers and just undifferentiated heavy lifting, rinse and repeat stuff. This is my most controversial tip. And I've had blowback on this, but I'm still going with it. It's okay to build a serverless monolith. This is okay. Seriously, it is. If you think about our architecture that I showed earlier, it was serverless, but this was a monolith when we started, right? One database, everything coupled to it. And it was okay, this got us to market. And they say software architecture mimics the setup and the scale of the team. When we started, it was me. So why do I need 30 microservices? And so naturally the architecture has evolved as the company has evolved, and we've been able to build out dev teams and bring on a lot more people. So this was a great kind of initial architecture to just get something out there, and I could just add more and more features, but it presented a lot of challenges over time. So the front end code is coupled directly to the database. So how do you add mobile apps? There's no versioned, consistent API for a mobile app to call, and people can have 1,000 different versions or older versions of your mobile app on their phone, and they're not updating them. So you've got to be able to service those requests. How are we going to scale, from 1 to 10 to 20 to 50 developers? That was a real question for us, without everyone just stepping over each other, because we had this single code base and single database. It was really difficult. So we decided to move towards this microservices architecture. And obviously you guys all know this kind of architecture, but each distinct business domain is represented by a separate microservice, and each microservice is responsible for its own view of the world, its own database, its own GraphQL API. It knows what it does. And you can align teams to the different microservices. So this allowed us to achieve acceleration with kind of highly focused teams who own and are accountable for one area of the system, which was really good. And we moved the source of truth from Firebase over to DynamoDB. So instead of writing directly to Firebase, when a user needed to write a record or make a change, it would go through the API, through GraphQL, got written to DynamoDB, and then the wonder of DynamoDB streams, we rely on these so heavily, they're so useful. With DynamoDB streams, when a record gets updated or deleted or inserted into DynamoDB, we know Amazon's going to invoke a Lambda function to tell us that in a kind of reliable, repeatable way. And therefore, we're able to then go and push that record out to Firebase. And so what this meant is we actually wanted to move away from Firebase, but re-architecting the whole system was going to be almost impossible to do without a big bang 6-month project. But we were able to separate out the writes from the reads, and then slowly over time rework the user interface to read not from Firebase but from GraphQL. And we're still on that journey. We still read a bunch of, some of the legacy parts of our system still rely heavily on Firebase. It'll probably take us another year to get rid of it completely from that model. But I think the thing that was really interesting is that it allowed us to kind of migrate towards the new architecture in stages. And if you think about it, we migrated from a monolithic architecture to microservices without ever having to think about infrastructure. We never had to think about server provisioning, what are we going to do with our web farms, our load balancers. Over time, we have changed the entire architecture of the system from monolith to microservices just by making small incremental changes to a YAML file and then hitting deploy, right? CloudFormation takes care of it for us through serverless framework. I think that's absolutely amazing. It just gives you so much power and so much nimbleness. I think, one thing that became really apparent over the past few years is that going serverless really amplifies the need for good development practices. Some of those things that you always strive for, and everybody says they do TDD, but how many people have been on a project where budgets get in the way, timeframes get in the way, and things just need to get out the door. So I think the really interesting thing about building a serverless system is those things are not optional. So there's a couple of lenses to look at this through, and the first is that automation is not optional. Serverless systems are distributed systems. They have hundreds, probably really thousands of moving interconnected parts. Once you scale past just a few functions, you can't deploy these systems manually. It's not possible. There's just too many pieces to upgrade and connect together. So automation is kind of baked in by default. Then obviously, even just when you've got thousands of moving parts and then you multiply that by the complexity of running multiple environments for developers, testers, UAT, production, you just need to be able to roll it out in a very repeatable, automated fashion. Frameworks like Serverless Framework are really helpful like that. They've really contributed to the ecosystem here. And we struggled in the early days, too hard for too long to build our own deployment systems and, literally on grunt and bash scripts to just call the AWS CLI. It wasn't very scalable. And then the second lens is the need for testing and high code coverage. So you can't run a serverless system in a local development environment. They are cloud native. So you can never fully emulate the cloud, the operating environment, for development purposes. And we had a lot of problems with this early on. So you might be able, let's say you can emulate one function. You're writing in JavaScript. You can run Node.js on your machine and you can use an emulator and you can emulate that function. But your function writes to an S3 bucket. Well, those S3 buckets can, or an SNS topic is configured to launch a Lambda. So now you're testing locally, and now you've got a Frankenstein system that's now running code in the cloud, right? So you just can't, it's just not possible to fully emulate a cloud environment locally. I know Azure have been working on this with Azure Stack, but that's a whole other thing. Certainly can't do it on AWS. So we didn't have a lot of unit tests early on because, I was just trying to work out if anyone wanted to use our product and buy this thing. So we had to just try to see if we could make this thing fly. So a lot of our testing was manual on local development environments. But you couldn't run Lambda locally. And then we got into what I call the cycle of despair. So this is where you write your code locally on your computer for your function, you save it, then you go and you upload it to AWS, and that takes used to take a minute or two in Australia. It was really painful. Then you'd run the thing locally in your web browser with a local website that would call out to functions in the cloud. You're going to invoke these functions that you're working on. And then, of course, the thing fails. As previous speaker talked about earlier with Murphy's Law, of course, it's going to fail. So you go, what went wrong? All right, well, now I need to open CloudWatch in the browser. I need to trawl through a bunch of logs. I need to find the issue. And then I go back to the start of the cycle of despair, update the code, and do it all again. And it's a nightmare. It was an absolute nightmare. And I hope nobody develops like this anymore. So I think for a while we tried a range of different solutions to emulate the AWS cloud environment locally. There was things like serverless offline, serverless simulate. They're trying to simulate API gateway, and then there was a simulator for DynamoDB, but you just can't simulate AWS. So they all became Band-Aid solutions. And so what we realized is that the way to solve this problem permanently is a solid unit testing strategy. You've got to have high code coverage. You have to isolate each function in your serverless system and test it very robustly with unit tests. You need to be confident in the operation of that single function in isolation, so each part of the system. And you can run all your tests locally on your development machine as you write them. So you build against your tests. I mean, that's typical TDD, right? Your tests should be the very first user of your system. Number 9, we're getting there. We're close. So I think one thing that's really important to think about as we move more into this cloud-native world, and a serverless just enhances it more, is that you are building against managed services, and managed services are moving targets. They do not stay still. And we had a lot of issues along the way where the service we're working with would change something or would make something obsolete, and we're left in a really uncomfortable position. So Firebase, when they got bought by Google, brought this thing into GCP, they decided to make their old version of Firebase obsolete, and there's a drop-dead date. On this date, your system will no longer work, right? And when that's your main database, that's a pretty scary prospect. And they gave a lot of lead time, but when you know what it's like, you're a small product team and you're trying to get features out the door to customers, you've got to just pull back and work on something that adds no more value to your customers. That's super frustrating. Amazon did this with Node 0.10. They deprecated support for that in Lambda, moved it, and so that was, for us, we had a bunch of functions from the early days that just worked. We didn't need to change them. We weren't iterating on them, but we had to go back and do all this work on things that already worked just to keep the thing running. So, it's frustrating, right? But the flip side, by using those third-party services, you are getting the benefit of them managing entire parts of your system for you. And you're getting the benefit of them also moving the game forward and, suddenly one day just adding a new capability and you can just turn that on. That's amazing. But the flip side is that they will pull the rug out from underneath you sometimes. And you just need to be accepting of it and always ready to move forward with them. It also really underscores the importance of doing your homework on a company before you let them become a really fundamental part of your system. You have to know who you're relying on and really do your diligence. So we went from nothing to a serverless monolith, which is great, to serverless microservices, and we worked out how to build without local development environments, how to attract great talent, and how to run an ops team that spans a whole bunch of companies. And that, I guess, leads me to the last tip, number 10, which is have fun. This is a really, really exciting time in our industry. Just the power we have at our fingertips now through the cloud providers and all these third-party services is just insane. So I just encourage you to get involved. If you have some interest in serverless systems and serverless cloud computing, give it a go. You can just start with something small. You can build a little project. You don't have to eat the whole elephant at once. I think all in all, building an entirely serverless application has a lot of advantages, and it's been a lot of fun. It's presented a whole bunch of interesting engineering challenges along the way. It's certainly not all rainbows and unicorns, but I do firmly believe that it enabled us to get to market as a business, and then once we're in the market, move at a pace in the first year or so that we just couldn't have otherwise. So we wouldn't have a business without serverless technologies. So that's that. I think I'm going to insert one very small, shameless plug before we go. We are looking for people in Melbourne to join ACG. There we go, sorry. Looking for full-timers, freelancers. We have some people here in grey ACG shirts. If you're passionate about cloud, any cloud, come and see us. We've got great roles where you basically can become an instructor or editor and get paid to learn, which is pretty cool. But look, thank you for listening to me rant about serverless technologies. It's really nice to be here today. Cheers.